Hey everyone, welcome to this session Image Processing with Python. So before start the session, let me introduce myself. I am Shampriti from Great Learning. And please guys let me know I am audible to you or not. If I am audible, then please put a yes comment to the live chat for that we can start the session. And in the meanwhile, let me introduce that Great Learning has come up with a brilliant idea, that is Great Learning Academy platform, where you will get almost 80 plus free courses, and after complete your course you can claim your certificate as well. And if you want to do these courses on your mobile application, that is also possible using Great Learning app. So please go and use the opportunity as much as you can. Skill up yourself, use this pandemic situation, and yeah, you will get so many new courses and they are really help you to actually skill up your knowledge as well. Okay, I can see some of the yes in the chat box, so that I think we can start the session, right? Okay, so I got a question from Sarvit. Is this theoretical session or a practical session? It's a practical session as well as a theoretical session as well. Please wait, I will discuss the what agenda we have for today's session. Okay, so today we will have a look at what is image processing, and we will see that what is the traditional machine learning process to do the image processing, and what is the new the more accurate way of doing image processing using deep learning. Then we will have a look at the deep learning concepts, and basically in today's session we will have a look at one of the most used algorithm of deep learning, that is convolutional neural network. And we will have a see the what is the difference between human brain and the artificial intelligence brain. So when we talk about brain, that time we came into the deep learning part, right? So we will have a look at those things. Then we will have a look at how image input work in computer. So if I am a human being, I can see an image, but how a computer can see an image, we will look into that. Then we will have a look at what is CNN, that is convolutional neural network, that comes under deep learning. Then we will have a look at a brief of CNN, that how CNN works, what are the layers we have in convolutional neural network. Then we will do a demo, that is we will have a set of images like dogs and cats, and then we will use a binary classification using convolutional neural network, how actually we can identify that images from a new image data set, that is a dog image or a cat image, right? So I think it's interesting session. I really like these things. So if you guys feel it's a interesting session, please let me know in the live chat, for that I can feel that it's a really interesting session. Okay, so first we will start with what is image processing. So we all familiar with image, right? So we actually process the image to get to do some operations, right? And to do some operation we need to extract some information from those images, right? So in that case image processing come into the picture. So when I'm talking about, I need to differentiate between dog or a cat image, right? So it's not possible by looking at the image for computer to understand what is the dog image and what is the cat image. So in that time we need to go for image feature extraction, and with those features, the features for dog image and the features for cat image is not same, right? So that difference help a computer to understand that what is the difference between those two images. So this is how actually image processing stands for. So it is one of type of signal processing. So if you guys from ECE background, electronics background, so you should have idea that what is a signal processing, or who doesn't have idea, so I can give a little one liner, that signal processing basically the way we talk, right? So your voice, so that voice also can be processed to do some text to speech or some other applications as well, right? So this is one type of a signal processing. In this processing, input is an image. So for image processing, our input is an image and output is also an image or a characteristic or features associated with that image, right? Okay, I can see from Anjal Hindi. Sorry, this session is not in Hindi, so I'm sorry for that. So maybe we will come up with the session that is in Hindi. Okay, okay, fine. So then have a look at a image, right? So maybe it's a dog or cat. How can you do that? So using machine learning to understand that a image is a dog or cat, that is a problem, because in an image there is a dimension. When we talk about the dimension, there is a lots of dimension we will get, but from a, like, in machine learning, what we need to do, we need to do a manual selection. But manual selection is a huge dimension, right? So it's not possible. So in that case, deep learning come into the picture, and deep learning help us to do those feature extraction part, right? It helps us to actually identify which feature is actually help our model to work with, right? So in that case, deep learning came into the picture. Now we will have a look at when we talk about neural network, right? So what is the difference between human brain and the neural network? We all know this, that a human brain is like the neural network is like a human brain. Most of them who actually starts their career or who starting learning this human brain and neural network, artificial intelligence, they have that doubt in their mind that how actually this neural network can be a human brain, because human being is actually a complicated version, right? So in that case, there are some part we actually can consider and compare with human brain with the neural network, right? So in that case, our human brain has dendrite, our human brain has axon terminals, but in the neural network, what we have activation function, we have input layer, we have hidden layers, right? So basically we have three part in a neural network, artificial neural network. Basically we have a hidden layer, we have input layer, and we have output layers. So this hidden layer is actually working as a black box thing. So if you don't know the mathematics behind that, so in that case you can say it's a black box. But if you know the mathematics behind this, so it is not a black box. This is one myth we know, that artificial neural network is a black box, but it is not a black box. It is a proper mathematical implementations, right? So basically scientists want to make a artificial neural network that works as our human brain works, right? So it is quite similar with that, but not fully similar with that. Now we will have a look at what are the thing we have in our human brain, for that we can compare with the artificial neuron. So in that human brain we have cell nucleus. So in that case, artificial neural network have node. In human brain we have dendrites, right? So in the artificial neural network we can replace them with input layer. That's the inputs, right? X1, X2, X3. Okay. In human brain we have synapses. So how can you replace that synapses out artificial neural network? So in that case we use weights or interconnection. This weight and bias helps us to actually calculate the inputs. This is the main part for an artificial neural network. Now we have axon in our human brain. So in that case, neural network has mapping, activation and learning. So lastly we have terminal axon, and for the artificial neuron we have output, that output layer. So if you guys have any doubt, I know it's a quite like uncommon topic, but if you guys have any doubt, just let me know. I will help you out and I will try to clear those out. Okay, so I got a question from Bharat, that why go for human brain versus neural network. So basically we all know that neural network is basically a replica of human brain, right? So who are actually new to this domain, they want to know what is the similar thing we have in human brain and neural network, right? So in that case, I just want to clarify you guys that what are the what are the thing we have in human brain and what are the thing we have in neural network, and how can we compare them, right? Okay, fine. So let's have a look at how a computer can see a image. So computer cannot see a image because computer doesn't have eye, right? So in that case, computer converts those images into an array of pixels, values. You can see this is a dog image, but for a computer is like, I don't know what image is this, right? So in that case, computer can see only the pixels, and that pixels is actually help us to do this processing, this image processing, right? So here you can see it's a color image. So for that, the dimension of this color image is 3. So if we have a image like a black and white image or a gray image, so that time the dimension should be 2, right? So this is the one main catch point when we start working with any image processing. So if you want to go for doing any image processing, that time you need to convert your like colorful image to black and white image, right? I got a question from Nirbhay that will you show a demo? Yes, I will show you a demo. Sabhit, okay, can you make us explain using some example? Yes, we will do that. Need demo in tools? No demo tools you need to know. Just just go through the session, you will get to know about that. Okay, so I got a question from Avishek. Okay, Avishek, how much GPU processing required to process? So for that, let me come into that part. I will show you what you need to use and how can you actually implement a image processing using convolutional neural network. So you guys don't need to worry about that, right? Okay, so I got a question from Tushar. Please share use case of neural network. Yes, I will show you the use case for neural network as well. So please stay tuned with the session and you guys will get all this doubt clarified, right? I got a question from Mayank. What is activation in artificial neuron? Okay, I will say that as well. Please wait and I will just give you all the brief, right? Okay, fine. So this is how a image can be seen by a computer, right? It's a array. It's a like a numbers for the computer. They don't understand the image, right? Now we will see what is CNN. So CNN is stand for Convolutional Neural Network, a feed-forward network to process and recognize image data with a grid version. So what is that grid version? So this grid version is this part, right? This pixels. So we can say the pixel, like through the pixel a computer can see a image, right? Okay, so first we have an input layer in CNN, then we have a convolutional layer, then we have pooling layer, and lastly we have a dense layer, that is a fully connected layer, and lastly we got a output that is in a form of probability, right? So if the probability near to 0, so we can say so this image is not belongs to cat, right? If the probability is 0 for the cat and if the probability is near to 1 for dog, we can say maybe this image is a dog image, right? So this is how we use our convolutional neural network. Okay, so I got a question from Nafis. Who is the targeted audience for this video? If you want, you can go for it because it's a very interesting one. So there is no target audience. So who has a, like who wants to go for and wants to understand that how actually our image processing works, they can go for this video. Okay. I got a question from Hisham. Can we implement the CNN with the help of libraries alone, or should we code everything on our own? Yes, we are going to use the libraries. We are not going to do the code from the scratch. Is this image processing is also used in biometric system? Yes, in the biometric system also we use image processing. So I got a question from Payal, why it is 3-dimensional. So basically in the 3-dimensional we need to go for color image. When our image is colored image, that time we have a RGB values, right? Red, green, right? Blue. So in that case we need to go for RGB values, and for that it is 3-dimensional. And when we have a gray color, right, or a black and white picture, that time we have 2-dimension. Okay, now we are going to see Reva, is OpenCV going to be taught? So for OpenCV we have another session, but this session I am going to show you how can you do all the thing using OpenCV plus convolutional neural network. Okay. I got a question from Kashyap. Ma'am, do you have a reference material for the CNN? So basically for CNN you will get the course material. Please check in the live chat, you will get the link for that, right? Okay. So now we will have a look at what are the layers we have in convolutional neural network. So we first have convolutional layer, then we have ReLU layer, then we have pooling layer, and then we have fully connected layer. So we have 4 layers in convolutional neural network to process our images, right? So in that case, first what convolutional neural network does, right? So let's have a look at one by one. So first layer is convolutional layer. So what convolutional layer does? So I told you that an image is already converted to an array. By that array, a computer can see those arrays, right? So convolutional layer help us to convert those images into an array, the first layer of CNN, and stores the pixelated values of image into an array, right? So this is the first layer actually help us to do the image processing, okay? And this layer is used for extracting the features of the image and reducing the dimensionality. So how we can do that? Let's have a pictorial visualization for that. Suppose I have an image, a dog image. So what are the pixels I have? I have 4, 21, 54, 92, 48, 2, 20, 2, 54, 36, 22, right? So in that case, what I need to do, I am going to use a filter. So when I start learning convolutional neural network, I actually got a big confusion that how these filters are going to use. So these filters are used randomly. There is no hard and fast rule. This is where your filter can be made, right? So in that case, our filter is 0, -1, 1, 1. So if you want to use a 3 cos 3 filter, I use a 2 cos 2 filter, right? So if you guys want to use any filter, right, and then values can be anything. So why we use this filter? We use this filter to reduce the dimension of the images. So in this case, the dimension of the image is very low, right? But when you have a HD picture, right, so we all like have a HD picture or a very high quality picture, right? So in that time, the image array will be a big one. So you are not able to work with those big arrays, right? So you need to reduce them. You just need to take the extract of that array, where your for this case you can see 22, 54, 36, right? These are the part of your image are actually having the actual image of a dog. So this is the basic part, this is the main important part of your image. So using filter, we try to extract those part. We try to extract that whatever the places we have in the image, they are actually highly featured. So in that, those parts we want to take and we want to process our images, right? I got some of the questions. Okay, Himanshu, please don't spam. Don't do this, okay? Okay, so I don't know what you are talking, Himanshu. Please don't spam in the chat, because there are really some candidates are there, they want to learn. So don't spam. Okay, so at anyway, I am not going to teach in Hindi. So please, for Hindi, maybe we will come up with the other session. Okay. So I got a question from Raghu. Can we take any number in filter? Yes, you can take any number in filter. That's not a problem. So the filter can be your, it's your choice, right? What you want to do, right? So in the filter, we use filter to actually get the main part featured part from the images. So for that we use filter, right? I got a question from Rakhunde. Is necessary to convert color image to black and white image? Yes, we try to, actually image processing can be done in the black and white image, not in the colored image. So yes, it's actually help you to do the image processing. Okay, so I got a question from Sneha. How to decide the pixel value? How is 3 to 22 minus 2? Okay, so basically pixel value, you don't need to decide it. It actually your images have those arrays, right? I will show you in the demo, right? So when you put a when you load a image into Python or anywhere, right? So that time what actually your computer can see a series of array. So you don't need to do that. Those arrays have the pixel values, right? Okay. So I got a question from Shilpi. Why not 42, 37, 86? Okay, so you are talking about this part, right? Extracted features. I will show you what actually I have done over here. There is a mathematical mathematical parts is there. For that you can understand how I get this new array, that is 3, 22, minus 2, 10, 23, 25, 87 and 139. ठीक है. So I will just let you know for that. If you can see, I have this part, right? 421 to 224 22, right? So what I have a 2 cos true matrix, right? Now what I need to do, I need to multiply with 4 into 0 plus 21 into minus 1, then plus 2 into 1, then plus 22 into 1, right? And then I will get a value for that, right? So let me do that. So I got a question from Azinkya that did you multiply pixel with filter? Yes, I actually did the multiplication and then the sum, and then I will get all this part, right? And if you do the multiplication of the whole image array with 0 minus 1 1 1, that time you will get this part, that 3 22 minus 2 10 23 25 87 and 139. This is how actually you can reduce the dimension, right? Mansi is, what are the mathematical values stands for? No, this is not the fixed values, right? So for my case, so for my image, right? So for my image, the pixel values are 421, 54, 92, right? But in your case, that can be something different. But for the filter, you can use any filter to reduce the dimension of your image array, right? So if you guys have any doubt, let me know. Ma'am, can you ma'am getting an example of it? Yes, I will give you the example. I'm just trying to make you understand the mathematical part of this convolutional neural network. I got a question from Dhamendra. How can you calculate matrix from filter or feature detector? So for calculating, you need to multiply that 4 into 0, 20 plus 21 into minus 1, then plus 2 into 1 plus 22 into 1, right? This is how we do calculation, right? Now we will have a look at activation layer. So what is the activation function, right? So when we actually do some convolutional part, that time we have an input, right? From that input we need to go for checking that if we have any minus or negative number or not. So we actually consider that if your value, pixel value is high, there could be a chances there will be some feature in your image, right? So in that case, what we do in the activation function, that is ReLU, we use ReLU. What ReLU does, it converts negative values into 0. So I already told you that if a pixel value is high number, right? So in that case we can say there can be a feature, right? So in that case you can see I have 87 over here, right? So 87 and 139. So I can consider this 87 and 139 has some feature, right? In the case of minus 2, we can say there is no feature because this is already belongs to minus 2. Okay, so in that case we can say that okay, this is minus 2, so there is no point of using this, so we can convert it to 0. So this is how we use ReLU layer. Okay, and whatever our pixel value is, we can say this is some of the feature is there in our image. Okay, so I got a question from Ashwani Kumar. Filter value not gate. Which filter? Okay, filter value can be anything, guys. That's not a problem. So Supriya, I am confused. What you are confused about? So some of them asking the calculation. So this calculation is very normal calculation, guys. 4 into 0 plus 21 into minus 1 plus 2 into 1, then 22 into 1. This is how we calculated each pixel. Okay, so here you can see this is why we use activation function. Now you can see I have a minus value, that is minus 2, and my ReLU layer, what it does, it convert that minus 2 to 0, right? So in that case we are using ReLU over here. So first we use convolutional layer. That convolutional layer help us to do the reducing of the image, okay, the dimension of the image and getting the feature from the image. Then we go for ReLU layer just to eliminate all the negative value from our image array. So there is no point of processing minus values over there, right? So we convert them into 0. Now we will have a look at the pooling layer. So what pooling layer does? So reduce the spatial size of the number of the parameters, right? So now I have some of the parameters, right? So in that case, Vivek, so this is not a matrix multiplication. So no, this is not a matrix multiplication. This is something different when we use image processing. So I got a question from Tej, how to decide filter value. Deciding filter value is up to you. You can use 1, -1, 0, 1, anything you can use, right? So again, Satyajit, I'm saying these things so many times, guys. Please follow that filter value can be anything to get the feature from your images, right? Please don't spam. Don't spam. Okay, fine. Now we will have a look at the pooling layer. So pooling layer actually help us to reduce the spatial size and the number of parameters. And this pooling layer actually help us to reduce the dimensionality as well and helps to control the overfitting. So if we have so many pixel values and if we want to train our model with that, my model can be overfitted. What is overfitting? Your model will start learning each and everything from the training data set, right? But when you give a testing data set to your model, it will start saying, I don't know what will gonna happen, right? So in that case, for the training data set, it will give you maybe 99% accuracy, right? So your model start reminding those, not learning those parts, right? So in this case, for pooling layer help us to do not to overfit our models, right? And normally we use filter size 2x2 for pooling layer. Okay, now let's have a visualization of how pooling layers work. So we got 3, 22, 0, 10, 23, 25, 87 and 139 matrix. Now we are going to use 2x2 pooling layer. But what is stride? Stride is basically how your matrix is going to move, right? If your stride is equals to 1, it will go by 1 column. If your stride is equals to 2, it will go like after 2 columns, right? This is how your strides works. Okay, I got a question from 100, 110 are the filter values. Raghu, I didn't get your answer. I didn't get it. Is filter value range of -1 to 1? No, there is no hard and fast rule that your filter value range should be -1 to 1. So I use that. Okay. Now what I did, I use a 2x2 matrix. So from that you can see 3, 22, 23, 25. I use the max number from the matrix because this number help us to understand, okay fine, this is 25, there will be a feature, maybe there is a feature in the image from there, right? So I took 25. Now I just shift my matrix 1 because my stride is equals to 1. What I did, I use 22, 0, 25, 87. From this, which one will be the highest? 87. So I took 87, right? Then I got a question from Dharmendra that if two or more images give the same matrix, two images cannot have the same matrix because all the images have some different pixel values and they have some different matrix, right? Abhishek, when we get image that was detected correctly on past, then we should say the image detection is 100%, not 99%. So Abhishek, I don't think that still AI can work with the 100% accuracy because if it's 100% accurate, then we can assume that your model is overfitted, right? Pile, please try it again. Okay, so basically what is it? You can see my matrix is moving with 1 column, right? So first it was 3, 22, 23, 25. So my stride is 1, right? So for that my matrix moves to 22, 0, 25, 87. But if my stride is equals to 2, right, it will go, then it will come to 0, 10, 87, 139, right? So this is how your stride works. Okay, now we will have a look at, you can see I got all the high range featured from the images, right? Now I have only 4 image pixel, right? So I don't need to process a lot with this. So this is why we are using this layer of CNN to actually reduce the number of pixel, and that will help us to actually process those images, right? Already I am giving the example, Supriya, that can you give one example of pooling layer? This is the example of pooling layer. First we have the array of 3, 22, 0, 10, 23, 25, 87 and 139. Now after pooling layer I have a array of 25, 87, 139, 139. Okay. Now we will have a look at flattening the data. Now this data can be 2D data or can be 3D data, right? But what is flattening the data? So converting pooled feature map into an array is known as data flattening. So let me give you a proper example for that. So I have a 2D data, but in CNN, when you want to use a CNN algorithm, that time they will not take any 2D 3D data. That time it will only take a 1D array. So flattening is basically done to flattening your data to 1D, right? So this is how we use flattening of data. I got so many questions, let me answer a few of them. Okay, so can you give one example of pooling layer? I already give that. Won't there be one value repeated always after pooling? So basically why 139 is repeated, right? So you can see when I am just shifting my stride, when I came to the last stride, right? So there is no other value. I have only 110 and 139. So this is why I took 139, right? This is how it actually works, right? Now I got a question from Raghu. How many types of pooling layer? So we have 3 types of pooling layer. Okay, sum pooling, average pooling and max pooling. I use max pooling over here. Okay, so I got a question from Siley, I can't even spell it out. Do we need to decide the stride value as 1 or 2? Yes, you need to decide your stride value. From that only your image feature is actually extracted. Okay, so is there any relation between data encapsulation and data flattening? No, Supriya. So basically data encapsulation is encapsulating your data, and data flattening is basically flattening your data from 2D, 3D to 1D, right? Okay. Okay, I got a question from, okay, ma'am, clear problems after lecture, ignore. Okay, thank you. Atul, interesting session, ma'am, thank you. Fine. So now let's have a look at the last layer we have in CNN. So lastly we have the combination of last layer, that is fully connected layer. So now I have 4 pixels, right? So I can process them. That will not take a long time to process them. So in that case, what I do using fully connected layer. In that layer, what I do, I reduce the dimensionality. It helps to control overfitting, and it also filter size can be 2 cos 2. Now let's have a look at the fully connected layer. So you can see whatever the input I have, that is 25, 87, 139, 139. Siley, if we use, see, using stride value, if you use stride value equals to 2, maybe there is a chances of data loss, right? So in that case, you need to understand that if you have a big array, right, so in that case if you want to go for stride equals to 2, that can be acceptable. But when your data set is not that big and you want to go for stride equals to 2, that time there is a possibility that you lost your data. So be sure about that whenever you go for any using stride or using any other like the filter, right, or the pooling. I use max pooling. So if you guys feel like we can go for some pooling, you can go for that as well. So I got a question from Sneha, why are we making the data into 1D array? So this is the basic part, right? This is the basic thing. When you actually want to process your image, that time your array should be in the 1D array. So you guys will be cleared after seeing the code. So in that case you can understand, if we don't flatten my data, that time it will not take your input. Ma'am, can we apply CNN on rather than images or text dataset? We can actually use CNN on image dataset only, right? Okay, fine. Now let's have a look at our demo part. This is the most interesting part. I really love to do demo on these things, right? Okay. Okay. So here I am going to use Google Colab. So if you guys want to know that sorry, how I actually use a Google Colab, let me show you that Google Colab. Go to Google Colab. This is actually featured by Google. Go there and click on Google Colab notebook. So you will get, Google Colab, right? So you will get the first link for that. Go for Google Colab. Why I am using Google Colab for this session? Because we need GPU. So what is GPU? GPU is a graphical processing unit. It helps us to process our data because we are using image over here. So in that case we need to have a proper GPU. If you don't have GPU, it will take a long time, guys, and we are actually have the time crunch over here. So if you don't have if you don't have GPU in your system, I should suggest you go for doing this thing in Google Colab. This is actually helpful. Okay, fine. Now what I need to do, I need to go to new notebook, right? So when I go to new notebook, that time you will get an option to change your runtime to GPU. So you can see there is an option of runtime. You need to click over there and just write change runtime. So you will get three options, that GPU, TPU and none. So normally default it is in none, but in this case you need to go for using GPU, right? So go for GPU and then save. So it will help you to actually do this programming with a very short time. Okay, maybe for the none it will take a long time, but for the GPU it will actually help you to process your images. Okay, I got a question from Rahul. Please make a video on cyber attack that happened on Twitter. Maybe we will come out with a session on that. Thank you. Fine. Supriya, thank you so much. Shukumar, thank you. Ekta, thank you so much. I am trying to help you guys who actually want to understand, who actually want to learn this data science or deep learning, and deep learning is one of my favorite part. Okay, Tushar, thank you. So let me go back to the code. Yes, so see, I just show you this is reconnected. Why it's reconnected? Because it's taking a lot of memory, right? In that case Google Colab is not able to handle that, right? So I always prefer you guys to go for Google Colab and using GPU. Okay, now let's have a look at the problem statement. So we have the dog versus cat dataset is a standard computer vision dataset, right? So in this part we will see how can you actually determine between dog and cat, right? So in that case my class 1 is dog and my class 2 is cat. Okay, so you can see there is a nice G file used to you guys understand that how actually convolutional neural network works and how you can actually use them, right? OJU'S is TPU processing. So TPU is basically used for some other cases, but if you want to go for image processing, I can suggest you go for GPU. You don't need to go for TPU. That's not even required, right? So now what we will do, so first I already have my dataset in the Dropbox and I just want to fetch that. To fetching those data I am going to use wget command, right? So already I have fetched those data. I have two dataset, that is training dataset and testing dataset. So let me just show you what I have. Okay, I will show you that what I have in the dataset, and my dataset is in a zip version. I want to unzip them. How can I do that? To do that I am going to use unzip command, and then the zip file I have, that is trainingset.zip. And for the test also we have Manshi, thank you so much. Piyush, will you be sharing Colab file? Yes, you will get this in Great Learning Academy. So just go and register for the course. Already our team is already sharing the link for where you will actually get all these materials. Okay, fine. Manshi, thank you so much. Dharmendra, thank you so much. How to wget data from Google Go Live? Okay, from Google Go Live, if you want to take the data, in that case you need to go for doing there is an option you can actually attach your Google Colab, Google Drive with Google Colab, right? So that time you don't need to go for doing wget, right? Abhi, how to find stride? Finding stride is up to you. How can you find this, what stride you want to go for? So normally I prefer to use stride equals to 1, but again if you have a big data set then you can go for increasing the number of stride, but in that case there is an option, maybe you can lose your data, right? Data loss can be there. Okay, I got a question. Achha, Ekta, can you please share this complete code? Yes, you will get this in Great Learning Academy. Ekta, thank you so much. So this is how we actually unzip our data, right? So you can see our data is unzipped, and I have a lot of data of dogs, right? I have a data of dogs and cat as well. So I am going to show you my data format, what I have. So you can see I have a test set, I have a training set. So let's go to that. You can see in that I have two folder. I have cat folder, I have dog folder, right? Fine. I will get back to you guys your questions. I will actually answer that. Before that, I just want to complete it, because this is a really interesting code I want to show you guys, and after that I will get back to your queries. Okay, so in training dataset I have two folder, one is cat, one is dog, and for the testing purpose also I have two dataset. So I have two folders, sorry, one is cat, one is dog, right? So this folder will be my classes. So you can see dog and cat, this is also dog and cat, so this will be my classes. Okay, now I want to show some of the images from that. So I am using matplotlib mpimg. So matplotlib is basically used to visualize image. So instead of matplotlib you can use OpenCV as well, right? So for that there is a function called imread. Okay, so this imread, and then you need to provide the path of your image, right? So in this case I use this, or if you want to take a path, let me just open that. So in that case you can see there are a lot of cat image I have, and just copy any of the path from there, right? So here I have this, maybe you can use something another, right? Control V, let me just do that. Yes, you can see I got some other image, right? So you can take any of the image from the cat folder and or the dog folder, and you can just see that how your image is actually working, right? Now what I did, I actually take a image from dog folder as well, right? So there are lots of image we have. Okay, so you can see I got a test, image from a test set, right? So this is also, it's showing that yeah, I have two folder, and that two folder also have a dog and cat image. Okay, now what I need to do, I need to import the library. So here I am going to use Keras. So Keras is basically built top of TensorFlow. So this Keras and TensorFlow are used to do image processing or any kind of, like if you want to make a model or deep learning, right? So in that case what we do, we used to go for importing TensorFlow of Keras, right? So my model will be a sequential model. Always the recurrent neural network, convolutional neural network, they are part of sequential model part, right? Then what I did, I take the import of layers. What are those layers? I told you that fully connected layer I have. So this fully connected layer in Keras known as dense layer, right? Then I have convolutional 2D layer. Okay, so in the convolutional 2D layer, so that is a convolutional layer, right? Then I import flatten layer, right? So I told you what are those: flatten, convolutional layer and dense layer. Then I took a max pooling 2D. So I told you that pooling layer, right? So I use max pooling, and I importing also max pooling 2D. Okay, then I import activation layer. And what is dropout? So dropout is basically preventing your data from the overfitting. Your model will not be overfitted, right? So for that it will suddenly drop out your neurons, right? So this, the neuron, the input layer we have, the input suppose 25, 36, 37, suddenly dropout will drop any of the neurons. Just for that your model will not start reminding it, right? So in that case we took dropout. Now if you want to see the version of the TensorFlow, you can see this is 2.2.0, right? This is the current version of TensorFlow. Then what we did, we given a image width and the image height, right? So for that I say that I want an image width of 150, and I got a question from Sumit, what is Keras? This is a deep learning library, Sumit. So we use Keras to build our model, deep learning model. Fine. Now we will have a look at that image width. So my image width is 150 and height is 150. I mentioned that. If you guys want to go for some other one, you can go for it. Then I define the directory of my data set. So my directory will be, if you want to take the directory, you just have to go there in the main folder and then copy path, right? So I have training set of folder, and under training set I have again one more folder, that is training set, right? Fine, Dipti, I will answer your question. Then I say there will be epoch of 20 and batch size of 20. So what is epoch? Epoch is basically help you to suppose doing a work, repeating a proper cycle again and again, right? So my case, the training part will be continued till 20. So 20 times my data will learn from the data. My model will learn from the data. This is how we use epoch. And batch sizes, so your model will not learn the whole data set at a time. So batch size help us. So I said take 20 sample from my data set and just train my model with that. And the next time take another 20 sample from my data set and then start train my model again. So this is how we use epochs and batch size. Now I am going to check what is the channel of my data. So what is channel? So basically channel is representing two ways. One is channel last, one is channel first. So if image data is represented in a 3-dimensional array where the last channel represents the color of channel, right? So how many color you have? 3, 2, 1, what you have, right? And then rows, columns and channels, right? So when you use channel last, and if you use channel first, right? So that time if I have 3 channel, so it will 3 is specifically for RGB value. So we use 3, 2, 1. So my rows is 2 and column is 1, right? So this is how, okay, this is how we use this channel first. So I want to check my data, my image, what is the channel I have, right? If k.image_data format equals to channel first, right? Then what you need to do, input shape equals to 3 image width, and I want my all of the image should be in a channel first data, right? So this is how we did it, right? Next what we need to do, we need to go for generating train model. So one image, from one image your model is going to build 3 to 4 images to get the edges from there, to get the features from there, right? So you can see I have one image but I have so many other images. So this is how our image generator works. Okay, fine. So in that case what I did, I called image data generator function where I said rescale equals to 1 by 255. So what is that? To normalizing my images. Then I said horizontal flip equals to 2, zoom range equals to 0.2. So you can see some of my images are actually flipped, some of are zoomed, right? So this is how our image data generator generate data. Okay, so I do this for train data generator and test data generator, both of the cases. And lastly what I got, I am getting sure that my model, whatever the thing I am doing, it's actually working. How can you do that? So for that you can see found 8005 images belonging to 2 class. For the test and for the training I have 2023 data, right? So in that case you can see that I have 2 class, dog and cat, this is right, and I have this much of images. So this is how your data generator are actually working. Now I want to see what my data generator done. So you can see my data generator what done. You can see some of them are actually zoom, some of they are actually rotate, right? So this is how our actually image data generator works. Ekta, thank you. Srushti, thank you. Okay. I got a question from Sushi. Can we have a session link or code? Yes, you will get all of them. Please look at the live chat. Our team will help out with that. Mayank, thank you. Piyush, you will get this file on the Great Learning platform. Right? Now comes the convolutional layer. So we have convolutional. Now comes the convolutional neural network part. Now I'm going to build my model. This is the most interesting part. So how can you do that, right? So in that case, I have 4 layers, we all know, right? So in that case, what we are going to do over here, first we are going to call that my convolutional neural network is a sequential model, right? So in that model, now I want to add first layer. What was the first layer? Let me know in the chat box. What was the first layer we use in convolutional neural network? For that I can understand you guys are actually listening to me. I'm waiting for you guys. I will wait for 10 seconds. Let me know what's the first layer we have in convolutional neural network. Come on, first I want to see. What's the first layer we have in convolutional neural network? This is not acceptable, guys. I'm literally repeating so many times that what we have in the first layer in the convolutional neural network. So we have I got a question from Raghu. Sequential, what is sequential? What do you understand by sequential? It will go one by one. So this is actually known by sequential, right? So your model will start going one by one layer. So I got a question, I got that. Okay, I can see that. Okay, you guys are actually responding. Yes, first layer is convolutional layer, right, convolutional 2D layer. ReLU layer, no, sort of, no, not a ReLU layer. Image converts into array, right? We use convolutional layer, right? Now what I am going to add, I am going to add an activation layer. So why we use activation layer? For what reason we go for activation layer? So we use activation layer to remove the negative part, right? To negative image pixel from our data, right? So this is how I am going to use ReLU. Then we are going to use max pooling 2D, right? Here I am saying that my max pooling will be 2 cross 2, right? I think you guys can understand what I am doing over here, what I told you in the normal one, right, in this presentation, and what I am doing in the code. So both are same, for that you guys can understand that, right? Fine. Viral 10, I will explain that. For filtering, we don't need to write filter over here, right? So what I said 64. Convolutional 2D 64 what? So 64 neurons I want to get from the output, and 3 cos 3 is my filter value. I am using 3 cos 3 filter over here, right? Okay, fine. Now then what I add a flattened data that will flat my data to 1D channel. Lastly, I have a fully connected data, that is last channel will have 64, right? And when I have 64, then I said no, I want one more ReLU. I want to check that is there any negative value is there or not. Okay, so in that case I am going to use ReLU again, just to cut off the minus or negative value. Lastly, I use a dense layer of 1. Why dense layer of 1? This is a fully connected layer, and where you will get your output. This is the output layer, guys, right? So output dense layer will always have a neuron or nodes, that is 1, right? Fine. So in that case I use 1. And lastly, I use a activation function of sigmoid. Why I use activation function sigmoid? So always in the output we get a probability, not a proper number 0 or 1. So if your number is near to 0, we can assume this is not the image. If your number is near to 1, so that time we go for saying okay, this is our answer of our model. So I got a question from Ekta. ReLU needs to be used twice. There is no hard and fast Ekta. This is the twice I use because just to eliminate the minus values. So you can use once, you can use thrice. This is up to you how you want to make your model. So you can see I got my model summary. So I have the layer convolutional 2D, activation function, then max pooling, flattening, dense, and again these 3 I have added more just to get a more accuracy, right? Lastly, I need to compile my model. how can I compile my model, right? So in that case I'm using dot compile. So my model is ready. Now in compile, what I'm going to write, I'm going to actually provide my data, right? Sorry, so in that case I use model dot compile, and I'm using optimizer. Why we use optimizer? Optimizer help us to understand that maybe your data is not right? So in that case optimizer help us to understand optimizing our input, right? Optimizing our model. And here I am using loss equals to binary cross entropy. And lastly, the accuracy matrix, and you can see I got the summary of that, right? And now lastly I'm going to fit my model. How can I fit my model? How can I train my model? My model is actually compiled, but now I need to give the proper data set of our model, right? So in that case we use dot fit generator function. You can see dot fit generation function feeds the model on data yield batch by a Python generator, right? So this is how we use dot fit generator. And I am going to provide training generator and epochs. Already I have mentioned that, right? So you can see in the I gave 20 epochs. If you guys want, you guys can give epochs can be 25, 30, anything, right? So I am not going to execute over here because this actually takes time. So if you guys want to do that, please use GPU to do that, because it will take lot time. So you can see the value accuracy, lastly I got 72.90. so if you add more epochs to it, maybe your model start working more tunely, right? More finely. Okay, lastly I am going to see the accuracy curve, right? So you can see this is the plotting one. So already you get the accuracy at 0.7290. If you guys want to go for checking the curve as well, you can do that. Otherwise you already got your accuracy, how your model is working. So you can see training part is this, and for the testing it's working fine but not too good, right? So maybe in that case you can add more model to your model. So add more layer to your model. And one more thing I just want to let you know, guys, for convolutional layer you can use any of the layer twice, thrice, anytime, any number of time, but be sure your data is not lost. But before just going for the output layer, you have to be sure you use flatten part, right? So without flattening your data you will not get your output. Okay, fine. Now lastly I want to see the predicted image. Okay, so you can see this is actually a dog, but it's saying it's a cat. Let me try to do these things with some other one. Maybe for this image it is not working, so let me check. Okay, so let me just copy the path. How it's going to work? Yes, now it's this case it is showing it's cat, right? So this is the main thing, like if it's 72% accuracy, maybe some of the time it's working fine or some of the time it's not working fine, right? So this was our whole presentation, whole session. I hope you guys understand, and I will answer some of the question right now, and if you guys have any question after that as well, let me know in the comment section, for that we can go back to you guys. Payal, I understand the presentation but not the code. What part you are not able to understand, that let me know. Okay, so I got a question from gaming, when to use sigmoid or when can we use softmax? So sigmoid function and softmax function are quite same. So yes, you can use softmax instead of sigmoid as well, right? Okay, so I got a question from Supriya. Ma'am, I am not getting the source code. Which part you are not getting, Supriya? Okay, I got a question from Viral, that transfer learning would increase accuracy. Absolutely fine. That transfer learning you can use BYJU'S or any predefined model that will help you. Maybe we will come up with some of the session where we are going to use transfer model or any pre-trained model, that is BYJU'S or something like that. Okay, So I got a question from Bhim. Is there any prerequisite for this session? So if you know Python, that will help you. Okay. I got a question from Srusti. Can we run this code on Jupyter Notebook? The thing is that it will take a long time because you will not get the GPU support in Jupyter Notebook, right? Fine. Supriya, I'm not Cola file. You will get the Cola file in Great Learning Academy. Okay. Supriya, yes, we can run in. No, we can run it, but it will take a long time. I should suggest you don't go for Jupyter Notebook. Okay, fine. So I got how much time left? Almost we came to an end to the session. How can the accuracy be increased? Using adding more layer to your to your model. That will help you to increase the accuracy, or you can go for using any pre-trained model. Okay, fine. I got so many query, guys. Can we get the source code? Yes, we will get the source code in the Great Learning platform, right? Okay, guys, thank you so much. I came to an end of the session. Fine. Thank you for so much for supporting. Thank you so much.